Hello, it's Tuesday, May 17th. Oh, just kidding. May 12th. All right, so today's FRQ actually goes back in time to scatterplots, independent, and extrapolation. This one was provided to me from the My AP Classroom, suggesting that you review it for your AP exam, whatever that means. So I guess it's a wink, wink, nudge, nudge. Here we go. The total race time for a 100-meter dash can be considered the sum of two variables, the reaction time to the starting signal and the running time for the 100 meters. The scatterplot shows reaction times and running times for 20 runners in a certain race. The winner was the runner with the least total race time. All right. Circle the point on the graph that represents the runner who won the race and the approximate total race time for that runner. All right, so we want the fastest run time. So it looks like here's my winner. There we go. So this winner ran the race in about 9.6 seconds. And the reaction time, this one was a little bit iffy. You're going to notice they accepted a range here, so it's okay if you don't have the exact same number that I chose. But I went with something a little higher than 15, but less than 16, so I went with 152. All right, so combining those two together, this person's race time was about 9.762 seconds, but anything from 9.75 to 9.765 is an acceptable estimate. So to get full credit for your E, they're looking for two things. They want you to circle the winner and show that combined race time. If you only did one of those things, partial credit. All right, on to part B, boy. Based on the graph, is it reasonable to assume that reaction time and running time are independent? Putting that in other words, aka not associated, right? If they're independent from each other, they're not associated. When you look at this scatter plot, you can clearly see a trend. All right, so there is a relationship here, right? We do have that positive direction. We've got that linear form. So to me, it's not reasonable. Right? It is not reasonable to assume these variables are independent because they sure do look associated, right? They look associated. There is a moderately strong positive linear relationship between reaction time and running time. So it is not reasonable to assume that they are independent. They are most likely dependent, right? They depend on each other. To get full credit, they wanted you to say not reasonable with the DOF, right? DOF. There were no outliers to worry about here, so just talking about the direction form and strength for your scatter plot as your support. If you only did one of those things, then it's a partial credit. All right, for part C, based on the least squares regression model created from the data, explain why the use of extrapolation to predict the running time for a runner whose reaction time is 0.3 seconds might not be appropriate. Right, notice 0.3 seconds for reaction time is not a piece of the data that was gathered. Right, we have no idea what's going to happen out there. That's called extrapolation. So there's two things we're looking for to get full credit. All right, a reaction time of 0.3 seconds is longer than the slowest reaction time shown in the graph. So that's kind of setting up the definition of what it means to extrapolate. The next thing is to talk about how extrapolation is unpredictable. The relationship of the variables beyond 0.21 is unknown. Therefore, the model might provide an unreasonable prediction for reaction time of 0.3 seconds. Going beyond data that you've already collected is it's risky to make predictions on, right? Models do fall apart. So, two things to get your full credit. If you only hit one of those things, then it's partial. All right, on to the next problem.